Alright, so again, what I said about this activity, special right triangle introduction, is this is the new topic, the last topic for the unit. And we want to look and see if we can find some patterns in these particular right triangles. Okay? So look here with me. Notice that in the 1 through 6, all of these triangles have the same angle measures. So repeat after me. 45, 45, 90. So those are the three angles here. So that is a 45, 45, 90 is a quote unquote special right triangle because there is something unique amongst its three sides. The great thing is you won't ever have to use the Pythagorean theorem to find these three sides after you learn this trick or relationship. It's not a trick, it's mathematically true every single time. But it only works on a 45, 45, 90. Say that.
45, 45, 90.
All right. So, answer number 1 here. The leg, we have two legs. They're the same. Number 1, this side length of 1, side length of 1, because the angles are the same. The angles and the side lengths of triangles have a connection. If you ever have an isosceles triangle, two sides are the same, you're going to have two angles that are the same. And because we have a 45, 45, 90, that's forcing our two legs to be the same. Okay? Now we want to, in every single one of these problems, you are solving for x, and that's the hypotenuse. So now I want you to look and help me see this pattern from the leg to the hypotenuse. Length of 1, the hypotenuse is square root of 2. Leg is length of 2, the hypotenuse is 2 times the square root of 2. Leg length of 3, the hypotenuse is 3 times the square root of 2. What are you noticing? The square root of 2 is showing up every single time. And the leg length is in front when you put it in reduced radical form. So for those of you that do not have 4 and 5 done yet, we wouldn't even have to do the Pythagorean theorem. If you see that pattern, the length is 4 of the leg. X has to be 4 times the square root of 2. Number 5, the length of the leg is 5. Hypotenuse is going to be bigger. How much bigger? Times the square root of 2. Every time. And this is for a 45, 45, 90. So here on number 6, where it says, for any 45, 45, 90, if the length of the leg is A, right? Any size. A is any size. To go to the hypotenuse, we will multiply by the square root of 2. So that is one connection for today. What if I didn't tell you either leg, and I said the hypotenuse is 20? You think you could go backwards? Right? So instead of multiplying by the square root of 2, we would divide by the square root of 2. Because we won't have any decimals, we still want these to be in exact answers. The only thing I have to show you today is what happens if I take 20 times the square root of 2 or 20 divided by the square root of 2. How do they work together? How can we simplify them? Okay, that's where we're going after this to finish up class today. We will formalize this connection between the leg and the hypotenuse in our notes when you come to class next time. Okay, so we're going to do this second part together here. It looks a little bit different. We're not going to use the Pythagorean theorem. Okay, but I need you to notice here, write this down. the larger triangle is a equilateral triangle. What's an equilateral triangle? All sides are equal. And if all sides are equal, all angles are equal. Okay? So when I say larger triangle, I am referencing the outside edges here. Okay? All sides are equal. So if I draw a triangle and I say it's equilateral, this side is equal to this side, equal to this side. Okay? And I know this whole bottom piece has a length of 1 and a length of 1. So this whole segment is a length of what? 2. What does that make x? 2. This whole side is 4. What's the length of x? 4. This piece is 3. What's the other piece going to have to be? 3. So we have an equilateral triangle that has what we would call the height drawn in. The height of a triangle is measured at a right angle, right? When you measure somebody, you have them perpendicular to the ground. We've talked about this a lot. It's dividing this top angle, which a moment ago we said was 60. It's dividing that top angle in half, just like it was dividing the bottom leg in half, or edge. So if I look at just one triangle here on number 11, this is half of this picture. So its special name, repeat after me, is 30, 60, 90. Okay? 30, 60, 90. Write that down above number 11 here. 30, 60, 90. And so it's not equilateral or isosceles. The 45, 45, 90 had two equal legs. The two legs here on number 11, they are not equal. So we are going to designate the smaller leg as the short leg, SL. We are going to designate this other leg as the long leg, LL. Okay? Short leg, long leg, and we still have the hypotenuse, HYP, for the length of X. So if we go back here, this 5 is now half of the original equilateral triangle. Okay, so let's go back to number 10. If this little piece is 4, this whole thing is 8, so this side is 8, right? Because all the outside. So if this is 5, what does that make X? 10. So how do you go from 5 to 10? It's what? What's its mathematical connection? Times 2. So if no matter, when you have a 30, 60, 90, if I tell you the short leg, and I ask you what is the hypotenuse, or you need to find the length of the hypotenuse, you're going to multiply by 2. And if I give you the hypotenuse, and I say the hypotenuse is 15, and you need to go to the short leg, you will divide by 2. Okay? So that part isn't going to be like math that we need to practice, how to multiply and divide by 2. You know those particular rules. Okay? Let's take 3 minutes right now. There's going to be another pattern emerge. I want you to do as much as you can on 13, 14, and 15. You do need to go back to the Pythagorean theorem here, and you're trying to find a connection between the short leg to the long leg. We've already given you those details. Now on the hypotenuse, I still have it wrote as 2 times 1, 2 times 2, 2 times 3. You can simply replace those values as 2, 4, and 6 going across here. So again, 2 times 1, this is not 2.1, this is 2 times 1 from that other discovery we just had, but this was twice as big. So this side is simply a 2, this side is simply 4, and 6. Okay? So use the Pythagorean theorem here to find the length of x on 13, 14, and 15. You will not have to ladder on 13. You would, again, have a small ladder on 14, 15, 16. There's a little bit different on 13, 14, 15 for the fact of we're not finding the hypotenuse here. Make sure that you don't have x squared by itself on these, on your setup. We're finding the leg. The hypotenuse is given. So we have 4 equals 1 plus x squared. We subtract the 1 from both sides. We have 3 equals x squared. We square root both sides. X is the square root of 3. 3 is prime, so there is no ladder for number 1. Okay. Number 2, we have 16 equals 4 plus x squared. We subtract 4 from both sides. 12 equals x squared. We square root both sides. Square root of 12 does reduce. If you were to ladder over here, we're going to get 2 square root of 3. On 15, we have 36 equals 9 plus x squared. We subtract 9 from both sides. 27 equals x squared. Square root both sides. We create the ladder for 27. You're going to get 3 3s, right? So a pair of the 3s would go out front, and that 3 would stay inside. Okay, so there's another pattern here, kind of like in number 1, where we are looking at the length of the leg, short leg, and we're solving for the long leg. Length of the leg is 1. We got square root of 3. Length of the leg is 2. We just got 2 square root of 3. Length of the leg is 3, and we're getting 3 square root of 3. So even if I don't want to work that out, then for the last, right, 16, 17, 18, we know the length of x on 16 is going to be 4 times the square root of 3 to get to the x. And short leg to long leg is going to be 5 times the square root of 3. So our generalization here, we've already talked about going from short leg to hypotenuse. So length of A times 2. But to go from any length of a short leg to the long leg, we're going to multiply times the square root of 3. So what is unique about these 45, 45, 90 and the 30, 60, 90 is that you can determine the other two legs with only one side length because we don't have to use the Pythagorean theorem. If you forget these connections, okay, you can always, and I only give you one side, you're always going to have angles. You could always use trigonometry to find the answers, okay? But once we start using these over and over again, I think it's going to become pretty clear which connections we have made, and you're going to memorize them pretty fast. In my opinion, the only thing that's tricky is one of the triangles has a 2 as the side correlation, and the other one has a square root of 2. And sometimes students are like, I know it's 2, I just can't remember which 2 it is, okay? And so how we discovered these can help you to think about that as well.